Hello, game theorists. So in case you could not get enough game theory, I have one more video for you guys. This is about the final extra credit game. So we learned about all pay auctions in class. So highest bid wins, but everyone pays their bid whether or not they win. So the stakes here are one extra credit point. So as an example, if Richard bids 0.7 and Daniel bids 0.4, Richard has the higher bid, so Richard gets the one extra credit point. He pays his bid of 0.7, so overall he gets 0.3. Because in all pay auction, Daniel still pays his bid even though he loses. So Daniel loses 0.4 points. So as you can see, it's definitely possible to lose points in this game, so participation was optional. Now, we established in class that there is no pure strategy Nash equilibrium to this game. Instead, there's going to be a mixed strategy equilibrium, so the players are going to want to randomize. And I'll just do a quick recap of how that randomization process works. So P of B is the probability of bidding less than B. We have about 40 students here, so winning the auction means outbidding 39 others. So the probability that 39 bids are less than B is going to be P of B raised to the power of 39. So you write down your expected payoff. So if you win the auction, you get one extra credit point, but then you pay your bid B. So your net gain is 1 minus B. So you get that 1 minus B with probability, P of B to the 39, that's the probability you outbid 39 other students. If you lose the auction, you just pay your bid B because it's an all pay auction. You pay whether or not you win. So you get minus B times the probability of losing. So if you win with probability P of B to the 39, you lose with probability 1 minus that. So you do some simplification and you get an expected payoff of P of B to the 39 minus B. So your book, by a rather dubious claim, says that you can use the opponent's indifference property. I'm not quite sure that actually is a proper understanding of the opponent's indifference property, but it does give the right result, so that's why I stuck with it in class. You set equal to 0, and then you solve for P of B, and you get that P of B is going to be B raised to the power of 1 over 39. So this big P of B, that's your cumulative distribution function. So I drew a graph of it here with a computer program. So you should bid less than 0.1, looks like about 94% of the time. You should bid less than 0.2, looks like about 96% of the time. So most of these bids should be very, very low, between less than 0.1, almost all will be less than 0.2. Maybe only a handful of a class of 40 will be any higher than 0.2. So that's the cumulative distribution function. You can also talk about the probability density function. So for this one over here, this is just the derivative of the first one. So derivative of P of B is the probability density function. And for the probability density function, the area is the probability. So the probability bid less than 0.2 is going to be the area under this curve from here all the way up to there. And so on. So you can see most of the area is going to be much less than 0.2, and even less than 0.1. So that's how it works in theory. And that's what we talked about in class. We derived this result for all pay auctions. Let's look at what you guys actually did. So remember, bids above 0.2 should be very, very rare. Well, most of you guys did bid very low, which was according to the theory, but there was a substantial number of you guys who bid very, very high. So we have 3 students who bid above 0.9, and 2 of you also bid above 0.8. So 5 students total of a class of 40 bid above 0.8. So 5 out of 40 is 1/8. That's 12.5%. That is a lot of overbidding compared to what a theory says. Remember, the theory says that 96% of you should be bidding less than 0.2 and 94% less than 0.1. So it seems when you play this game in practice, there's going to be a lot of overbidding. Most I had played this game with my class last semester. There's also a substantial amount of overbidding. So I'm actually not quite sure how to explain this because we did go through a theory in class, and we even had some questions about it in like the homework and practice problems. So if you knew how to bid, why was there still overbidding? If you could shed some light in your thought process, go ahead and leave a comment. I'd be very curious to see what you guys are thinking. So I guess that's our very last video for the semester. Take care and stay safe out there.